Hello, welcome to video number 58. This is about using the distance formula. You're going to need a calculator for this. The distance formula is kind of intense, but once you get used to it, it's not so bad. First, I want to remind us where the distance formula came from. So we were studying in class how to find the distance between 2 points given their coordinates. We have a little diagram here. We want to find the distance between A and B, and that would be the length of this red segment here. So usually we call it C because it's the length of the hypotenuse, but because I'm interested in distance, this time I'm going to call it D. Then we got to use the Pythagorean theorem to find out what D is. So what we mentioned in class is the length of the bottom side of the triangle here. That's how much x changes as we go from A to B. It's the run. And the way we get it is subtracting the x coordinates. The x coordinate of B is 15, and the x coordinate of A is 3. And I'm actually going to leave it like that, because if I leave it like that, we're going to see where the distance formula comes from. So, all right, how much does y change? As we go from this point straight up to that point, the y coordinates change. So the change in y, which is kind of like the rise between the 2 points, is 12 minus 7. And again, just because we're trying to see the distance formula, where it comes from, I'm going to leave it like that. Okay, now, in order to use the Pythagorean theorem, we got to do this quantity squared plus that quantity squared equals d squared. So we would do 15 minus 3 squared plus 12 minus 7 squared equals the distance squared. So I didn't simplify because in the distance formula, it's not simplified. Okay, now that's actually almost it. All I have to do is take the square root of both sides because I don't want distance squared, I just want distance. So usually we put distance on the left here. It'd be the square root of what I have there. It'd be the square root of 15 minus 3 squared, that's the run squared, plus 12 minus 7 squared, that's the rise squared. And that would be the distance. All we did was use the Pythagorean theorem. And again, I left it unsimplified. That's because when you compare it, it looks exactly the same as the distance formula. The distance between 2 points is equal to the change in the x values squared plus the change in the y values squared. That's just the length of the horizontal side. That's the length of the vertical side. And it's all just Pythagorean theorem. So if you kind of take a look at what we were doing here to solve this and the distance formula, you see that maybe where the distance formula comes from. Okay, we won't go through this one more time, but this time we just have our points labeled kind of generically here. x1, y1, and x2, y2. So they could be the coordinates of any points. So down here, just like I did in an example with numbers, the length of this side here is how much x changes as we go from A to B. It's the horizontal change. And that would just be x2 minus x1. And the y variable, it changes by y2 minus y1. So if we want to compute the distance between the points using the Pythagorean theorem, we could do whatever the first leg is, so whatever that is, squared, plus whatever we've got for the vertical leg, squared, that has to equal d squared. And then we take the square root, so d is the square root of that mess. x2 minus x1 squared plus y2 minus y1 squared. Okay, that's it. I just took the square root of that. It looks intimidating. It's the square root of that whole thing. Okay, so that's the distance formula. Now we're going to use it. So I have it copied here until you get very familiar with it. To be honest, you should probably write it when you're solving a problem using the distance formula for a little while. And that's how you kind of memorize it. You just kind of write it every time you do a problem. Very soon you'll remember it. But here we have it here. So we just got to plug in the coordinates of the points. So we get d equals big square root. So make it really long. We have x2 minus x1, 22 minus 7. I'll kind of write everything out. Squared plus. Then y2 minus y1, 20 minus 12. And all of that is squared. Now, this is kind of a big calculator problem. I really advise not trying to do the square root right away. I really advise trying to simplify what's inside first. So you can even enter the whole inside in your calculator if you want. I don't think that could go wrong. But often, because of the way the calculator that handles parentheses, people kind of mess this up. So, all right, I'm going to work out the inside. 22 minus 7 is 15, and 15 squared is 225. 20 minus 12 is 8, and 8 squared is 64. So I almost have it. So I get d is the square root of 289. If you actually try that, I believe that that's 17. Let me give it a try. So square root of 289. It is 17. So the distance between those 2 points was 17 units. Now, usually if it's less than 100 or so, I kind of expect you to simplify the radical because we did so much of that. You should be able to kind of know no matter what size it is. But at least give it a try and see if it's a perfect square. This one is a perfect square. If not, maybe I would have left it at square root of 289. Okay, so here we go. One more example. This one has some negatives, so we got to be a little bit careful. So follow the formula exactly. Do x2 minus x1, whether they're positive or negative. So it'd be 1 minus a negative 4, because x1 is negative 4. So don't drop the negatives. Plus y2 minus y1, whatever they are. So it's negative 5 minus 6. So I'm following the formula very carefully. Now, you can put the whole inside in your calculator. I'm going to kind of go without that. So that would be 5 squared, which is 25. That's negative 11 squared is 121. And so we get d is equal to the square root of 146, which actually doesn't simplify. So again, if it were smaller, I'd hold you to simplifying or at least trying. But I'm okay with you leaving it like that for now. Okay. All right. Next example. So throughout this unit, we're going to apply the things we learned to triangles and quadrilaterals. We're going to see a little bit more of that very soon. And this is our last example. A triangle has vertices A, B, and C. We don't see a picture of it, but we don't need a picture. We can use the distance formula to find the length of each of the sides and then find the perimeter. Okay, so we just got to apply the distance formula a couple times. All right, this first time, d is the square root of, now I'm looking at points A and B. x2 minus x1 would be 6 minus 1 squared, plus y2 minus y1 would be 8 minus 4 squared. So that's the square root of 25, and that'd be 4, so squared is 16. And so I get square root of 41. Okay, that's not so nice, but it is what it is. All right, so how about the length of side BC? Okay, so we're doing the second two. Same thing, use the formula. D equals square root of, we have 11 minus 6 squared plus 20 minus 8 squared, and that's equal to square root of, well, 11 minus 6 is 5, so squared is 25, and 20 minus 8 is 12, you square that, it's 144. We get the square root of 169, which, if you try it, is 13. So our first side was an irrational number. Apparently our second side's length is a rational number. All right, A and C, that's the first and the third one. So D equals square root of, all right, 11 minus 1 squared plus 20 minus 4 squared. And so this would be the square root of, that would be 100. And 20 minus 4 is 16 squared is 256. So I get the square root of 356. Wow, I think 4 goes into that. Yeah, so I'm going to go ahead and break this up. That's square root of 4 times square root of 89, which is 2 times the square root of 89. And wow, I believe we're done. That's as far as we can go with that. All right, so for the perimeter, all I can do is just try to add up the sides and combine like terms if I can. I don't think there are really any like terms. So I got square root of 41 plus 13 plus 2 times the square root of 89 if I did everything right. There's a lot of steps in there, a lot of things where we can make little mistakes. But hopefully we're really clear now after after we do it a few times, how to use the distance formula. And then this is just applying it to things we know. So we can ask all kinds of questions. What the perimeter is? We could ask, was this an isosceles triangle where two sides equal, or an equilateral triangle, or questions like that. All right, it's your turn. So we got one kind of big problem here for the journal assignment. Triangle has vertices P, Q, R, and go ahead and find the length of the three sides using the distance formula. So that'll give you really good practice. Here's the distance formula here. You might want to copy it in your journal. And then find the perimeter of the triangle. So add up the three sides and combine any like terms if you can. All right, this has been a little bit long, but this is a big topic. You're going to need this junior year. Talk to you later.